Moon Base and Beyond, the Lunar Gateway to Deep Space. Chapter 1. Moon Missions Past and Present. Imagine living in space. You are orbiting the moon aboard a new space station. The air smells of a weird mix of garbage and cleaning supplies. Fans and pumps hum as they constantly work to keep the air around you clean. LED lights make it feel like daytime. And through the window, you see clouds swirling over the blue globe of the Earth. Well, your day begins in the laboratory doing science experiments. Later, your spacecraft travels closer to the moon. You can clearly see its craters and peaks. Conditions are great for a trip to the surface. Dressed in your spacesuit, you collect rock and dust samples to bring back to the station. You hope to learn more about the history of the moon and the Earth from these samples. This scenario might seem far off in the future, but it's not. Astronauts could be living and researching in lunar orbit and on the surface of the moon by the mid-2020s. And here's a space fact. We always see the same side of the moon from Earth, and that's because it spins around at the same rate that it orbits the Earth. Early moon exploration. The moon has fascinated people for thousands of years, but humans didn't have the technology to get there until the 1950s. In 1959, the former Soviet Union successfully landed a small spacecraft called Luna 2 on the moon. And between 1968 and 1972, the United States National Aeronautics and Space Administration, which we call NASA, spent 9 manned missions to the moon. Japan, China, and India have sent unmanned moon missions too. Today, the United States has a new plan called Space Policy Directive 1. It puts exploring the moon at the top of NASA's to-do list for the first time in nearly 50 years. But the way astronauts explore the moon will change. The Apollo 11 crew spent less than 22 hours there in 1969, and future astronauts might spend 6 weeks at a time circling the moon and exploring its surface. Eventually, the moon could be a jumping-off point for places farther out in deep space, to Mars and beyond. Chapter 2, Gateway. NASA is leading an international effort to build the Lunar Orbital Platform Gateway. This mini space station, nicknamed Gateway, will orbit the moon. Astronaut crews will live and work there. They will test new technologies for exploring in deep space. Crews will stay at the Gateway for up to 6 weeks. Even when no one is living there, scientific tools on the inside and outside of Gateway will continue to gather data. Astronauts at Gateway will also make judgments about possible living arrangements for future missions. Perhaps they will discover that smaller habitats are too difficult for long-term missions. They might find better ways to use small spaces they have. Astronauts living on the International Space Station today have much more space than those on Gateway will. The inside of the International Space Station is about the size of a 5-bedroom house, but Gateway will be more like living in a camper. Gateway's design. Engineers have designed Gateway to have 6 or 7 units called modules. They will fit together to form the station. Each module will have a specific purpose. There will likely be 2 modules to house the astronauts. The astronauts will live and do research there. Another module will provide solar electric power. That electricity will power the station's lights, computers, fans, and more. One module will serve as a docking port. This is a bit like a garage where spacecraft coming into Gateway can both park and depart from. It will also serve as an airlock for astronauts going on spacewalks. There will also be modules for power storage and communication, as well as for intake of cargo deliveries. And a final module, called the Orion spacecraft, could carry the crew out into deep space. Building Gateway. So, how and where will Gateway be built? The plan is for unmanned rockets to send the various parts for Gateway into space. The lunar modules will then be assembled while in orbit. The first Gateway hardware is scheduled to ship from Earth in 2022. The power and propulsion element will be shipped from Earth first. Now, this PPE for propulsion will maintain Gateway's position and move it between different locations. It will also provide Gateway's communications. Several other parts will be launched after the PPE, followed by the airlock. And later on, another module will allow cargo missions to bring the supplies to the Gateway. Now, how an airlock works. Humans cannot breathe in space, and because of this, space stations must have something called an airlock. It's a small room between outer space and the space station. It keeps the air from leaking out of the space station, and to go on a spacewalk, an astronaut dressed in a spacesuit would step into the airlock. The outside door would be closed, and once inside, the astronaut would close the inside door. All of the air would then be pumped out of the airlock. Then the astronaut would open the outside door and head into space. Now, building Gateway will likely be an international effort. Russia may be building the airlock module, and Japan may provide a unit to help communications and propulsion. Canada might construct a robotic arm for outdoor work at Gateway, and NASA will provide one housing module. One of its international partners will provide the other. Scientists from around the world could benefit from Gateway. NASA officials think that the Gateway could be ready to house astronauts by the middle of the 2020s. Chapter 3, Moon Vehicles and Landing. Space agencies and private companies are currently working on developing new space vehicles. One spacecraft is called Orion. Astronauts will travel to and from Gateway in Orion. This exploration vehicle is built for deep space. Orion could travel to Mars or even an asteroid. Orion needs a boost to be lifted into orbit, so it will launch on top of a giant rocket called the Space Launch System. It will be able to launch Orion while also carrying heavy cargo, such as Gateway modules and landers, and it will carry more cargo to lunar orbit than any previous vehicles. The Launch Abort System, LAS, is an important part of Orion. In case of an emergency during launch, the LAS would propel the crew module a safe distance away from the rocket, and a parachute system would allow the module to land safely back on the ground. The LAS breaks away once Orion reaches orbit. Fun space fact: shipping items from Earth into space could cost more than $25,000 per pound. Pretty crazy. Landing on the moon. When Apollo spacecraft traveled to the moon, it flew in a circular path about 60 miles from the moon's surface, and it was only able to land near the moon's equator. That won't be the case with Gateway. Gateway's orbit will vary in its distance to the moon's surface, and the astronauts aboard Gateway will be able to choose where they want to land on the moon's surface. This will give them far more opportunities to learn about different parts of the moon. And the parts can include the moon's poles, impact craters, and lava tubes. Once Gateway crew members choose a location, they will take a special landing vehicle down to the surface. Now, in the past, different rovers or lunar vehicles explored the moon's surface and were then left behind. They are still on the moon. Today, space agencies are working to develop reusable vehicles to explore future missions. And a fun space fact, scientists have tested the incredible 10-foot-tall lunar electric rover in the Arizona desert. Its pressurized cabin has fold-down beds, a sink, a toilet, and even a collapsible exercise bike. Chapter 4, Science in Space. Well, humans have already begun to go to the moon. Gone to the moon. They've collected rocks from its surface. Probes have provided scientists with tons of information, but they have only scratched the surface. There's still so much to learn about the moon and deep space beyond. Instruments mounted on the outside of Gateway will help make observations of the Earth, the moon, and the solar system. Scientists will also operate robots remotely to explore the moon's surface more closely. And unlike humans, robots could explore in the vacuum of space without time limits. They could also gather samples on the moon's surface and bring them to Gateway for astronauts to study. Astronauts will send CubeSats from Gateway as well. A CubeSat is a tiny space-shaped research spacecraft. It's only about 4 inches long and it weighs 3 pounds. These tiny satellites could investigate asteroids or measure radiation. They may also seek out future landing sites at different locations in space. Fun space fact. 2 CubeSats, nicknamed Wall-E and Eva, were the first to travel to another planet. They headed to Mars in May of 2018. They completed their mission in November of 2018. I don't know if anyone has seen Wall-E, but it's a great movie, and you should check it out if you can. Humans in deep space. One goal of going back to the moon is to learn more about how deep space affects the human body. ISS crew members have made many discoveries through experiments using their own bodies. For example, they have found it is possible to reduce the bone and muscle loss in space with certain exercises. And you may wonder, if astronauts can learn about their bodies in space on the ISS, well, why travel farther from Earth? Well, deep space may affect the human body in different ways from low Earth orbit. Scientists need to know more about the risks of radiation exposure in deep space before sending astronauts to Mars and beyond. Crews aboard the Gateway will also have to hone their survival skills in deep space. They'll have to train for emergency situations in which they'd be too far to get help from Earth. Machinery might break. A crew member might have a serious health crisis. Astronauts need to plan how to solve possible problems before they occur millions of miles from home. Chapter 5, A Lunar Colony. People have dreamed of living on the moon for hundreds of years, but there are many challenges to living there. There's no oxygen to breathe. The temperature swings from minus 387 degrees Fahrenheit at night to 253 degrees Fahrenheit during the day. There is also no atmosphere to protect humans from the sun's dangerous radiation. A moon habitat would have to be airtight. It would have to provide a steady stream of breathable air for its residents without leaking. It would also need to be temperature controlled. A moon habitat must be very strong and sturdy. It would have to withstand space rocks that often rain down onto the moon's surface. It would also need water recycling system because water is limited there. A system to generate power would also be needed, and a place would be needed for residents to store and prepare food. It may even have a place for residents to grow food. The technology for such a plan is just starting to develop. Building a moon base. Building a moon base would be an enormous undertaking. Some experts think a great location might be in the deep craters near the moon's poles. These super cold locations likely contain frozen water, and astronauts could use this resource. And according to NASA, before construction for a moon base begins, robots might build the landing site for a moon outpost. 2 robots could stabilize the moon's loose soil. They'd also build walls around the launch pads. Using robots would be safer and less expensive than having people do this kind of construction. Now, water on the moon. For many years, people thought the moon was completely dry. But in 2009, a satellite called the Lunar Crater Observation and Sensing Satellite called L-Cross proved them wrong. The L-Cross was purposely crashed into a crater near the moon's south pole. The crash kicked up more than 26 gallons of water. This could provide a vital lifeline to those visiting or living on the moon. What might the construction process look like? First, a space rocket would transport the base of a moon colony. It would be folded up into a tube-shaped module. Next, an inflatable dome would stretch from one end of the module to the other, and this would provide a sturdy support structure for construction. Then a robot-operated 3D printer would make building blocks out of the moon's own dust, soil, and rock. These would go over the dome and provide a protective shell for the lunar base. Here's a space fact. Past lunar missions have left some interesting waste on the moon. It includes 3 lunar rovers, several cameras, a family photo, and nearly 100 packets of human waste. Humans in deep space. Whether on the Earth or in space, people must eat and dispose of their trash. But these tasks are more difficult and expensive in deep space. Humans must find creative options. NASA scientists think it may be possible for astronauts to grow plants while living on the moon. And in the future, space farms might provide the food needed by astronauts. These indoor greenhouses will have special lamps to help plants thrive in the controlled environment of a spacecraft. Space gardens could also recycle waste and make more oxygen. And for long trips into space, freshly grown produce would have more nutrients than food brought from the Earth months earlier. Now, managing trash in deep space will be a real challenge. ISS trash is loaded onto empty cargo ships and burned up during the trip back down through Earth's atmosphere. But there won't be many resupply missions to Gateway as there are to the ISS. Companies are developing ways of squeezing trash to make it easier to store. NASA is also exploring the use of biodegradable packaging material. And that just means it's a substance or an object that breaks down naturally in the environment. Now, the future of space exploration. Over the next 10 years, astronauts will likely learn a great deal about living and researching in deep space from the area near the moon. But in the near future, Gateway may serve as a jumping-off point for missions to Mars and beyond. It's an exciting time for space exploration and scientific discoveries, and we could discover more about the human body in deep space, about the moon, and about what lies beyond. But it will take an international effort to tackle the challenges of being farther away from the comforts of Earth. Well, maybe you will be an astronaut or a space tourist in the future. You may drop off supplies at Gateway for crew members on their way to an asteroid. Or maybe you'll find a space farm that will feed the hungry residents of a moon colony. In the not-too-distant future, maybe you'll help mine asteroids or leave your boot prints on Mars's red soil.